Inductive reasoning. So we are in 1.3 problem and problem solving and reasoning, and we shall do a video for inductive reasoning. So what is inductive reasoning? Well, it is a type of reasoning that forms generalizations or conclusions based on the examination of specific examples or specific instances of events that we are investigating. So let us use inductive reasoning to predict the next number in this list. Use inductive reasoning to predict the next number. 4, 8, 12, 16. Well, it just seems so trivial. The next number here is going to be 20. So 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 16, no, 4 times 4 is 16. And so 4 times 5, the next term in the sequence is 20. This is what you call multiples of 4. So a number is a multiple of 4 if it is equal to 4 times an integer. How about this one? What's going to be the next number in this list? Okay, so it just seems like the terms are the sum. Each of the term is the sum of the 2 immediately preceding terms in the list. So these 2 terms won't help us much. But we can get the pattern starting from 2 to 8. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. And you know now what's next. 5 plus 8 is 13. So this is how you do it with inductive reasoning. We are investigating or paying attention to the elements in your set, to the specific manifestations of the objects that we are studying, and from the patterns that we can see, we shall now produce a conclusion about the general pattern and the next element in the list. Predict the next figure. So problems like this are the sort of problems that you will see in abstract reasoning or IQ test. So IQ test, especially the part on abstract reasoning, is inductive reasoning. You are given objects and your task or the challenge to you is to see the pattern and use that pattern to guess the next object in the list. Okay, so how about this? What is the pattern that we can make from these objects? Well, the good thing is the polygons doesn't seem to change. It's a square and 2 triangles. But what about the numbers? Well, the numbers are perfect squares. Okay, 4, that's 2 squared, 3 squared. But this one is also a perfect square. This is 5 squared. Okay, so it just seems logical to say that the next number here is going to be 36. So after 5 squared, 6 squared is 36. And I am just imitating the pattern of placement of the numbers. Okay, up, down, up, down. But what about the smiley? Look at the smiley. Look at the smiley. Okay, so what pattern can you see here? Well, it just seems to me that the smiley is jumping from one corner of the square to the next corner. So it's like it's tracing the corners of the square clockwise. So from here to there to this one, and so it just seems reasonable to expect that the next smiley will appear here. Okay? So if you have other answers besides mine, please write that in the comment box. What about the next figures? Okay, let us pay attention to the arrows. Up, down, up, down, up. Okay, so down. But what about the number? Well, the numbers just seems to be like the sum of the 2 immediately preceding numbers. This is 1 plus 1, so that's 2. 1 plus 2 is 3. 2 plus 3 is 5, and then 3 plus 5 is 8. How about this? Okay, so let us pay attention to the polygons. So the polygon is a hexagon, 6 sides, pentagon, 5 sides, a square, 4 sides. So it's going to be a triangle here. Okay? But what about the smiley? 5, 4, 3, and then 2. Example 1.35, state a generalization. So we are given these terms. You call each of these as a term of a sequence or a term of a list. And so the challenge is, what is the general term? The general term is like a formula. What is the formula that will tell you the number that will appear in the list based on its position in the list? Okay, so that's the meaning of A sub n. It's the general term. Again, these 4 elements here, they are what you call the multiple of 5. It sounds so elementary, but having been a teacher of so many years, I'm telling you, there are students who would go to college and they are completely enumerate. Enumerate is like being illiterate in the universe of numbers. So this is what you call the multiples of 5. Multiple because it's a number that is written as a 5 times an integer. Okay, so that one is 5 times 1. 5 times 2 is 10. 15 is 5 times 3. And then 20 is 5 times 4. So the general term is A sub n is equal to 5 times n. How about this one? It's easy to see the pattern in the denominators. It's, okay, let us begin with 1/2. Because I think right now you are confused. Where is 2 here? Okay, but here, in the 3 terms, after 1, this is 2 raised to 1, 2 squared, 2 cubed. So you have an increasing integer exponent here at the denominator. Okay, but what about the first term? Okay, well, the first term, okay, you can write it as 1 over 2 raised to 0. Any real number that is not equal to 0, when you raise it to 0, it's equal to 1. So this number, in fact, can be written as 1 over 2 raised to 0. And the succeeding terms will be 1 over 2 raised to 1, 1 over 2 raised to 2, 1 over 2 raised to 3, so on and so forth. Now, what is B sub n? What is the general term? What is the formula that will help you write the term based on its position in this list? Well, it's kind of tricky. I think many of you would say it's 1/2 raised to n. It's almost correct. Okay, it's almost correct, but not exactly 1/2 raised to n. It's 1/2 or 1 over 2 raised to n minus 1. Okay, why n minus 1? Well, you must account for the first term because this is the first term. Okay, so the first term is equal to 1. But if you were to simply use 1 over 2 raised to n, okay, 1 over 2 raised to 1 is 1/2. So it's like you started from the second term. You did not start from the first term. Okay, so and also pay attention to the pattern here. So this is the first term, 1 first, but the integer exponent is 1 less than the place in the term. First term, 1 minus 1, it's 0. Second term, but the integer exponent there is 2 minus 1, which is 1. And here, this is actually the fourth term, but the exponent there is 4 minus 1. So that is why the general term should be written in this way. 1 over 2 raised to n minus 1, or I think I wrote it differently in the book, or you can write this as the quantity 1/2 raised to n minus 1.